Alright guys, so today we want to talk briefly about what we refer to as the outer electron configurations of elements. So if we think back to chlorine, for example, so I could write out the full electron configuration for chlorine, or I could write the noble gas configuration. So that is the noble gas electron configuration for chlorine. This piece right here is what we refer to as the outer electron configuration. So this is the part of the electron configuration that is more available to reactions. It is on the outer parts of the atom. So primarily when we discuss atoms and their reactivity as a result of their electron configuration, we're only concerned about the outermost electrons. So let's talk for a little while today about how to use the periodic table to determine an atom's outer electron configuration without going through this whole process. So let's take something like neon 3s2 3p4, for example. Okay? So if I gave you this electron configuration, this noble gas configuration, a couple of things we should be able to figure out right off the bat about this. First of all, we know this element is in period 3. Okay? So I can go ahead and write period 3. I know it's in the p block. Okay? And I know that its p sublevel has 4 electrons. So if we go back to the periodic table and we look at the p block, that would be 1 electron, 2 electrons, 3 electrons, 4 electrons. Okay? So this family has 4 electrons in its last p sublevel. So I know that this particular element is in group 6A. So then I could go back and find period 1, period 2, period 3, p block, group 6A. I know that this element is sulfur. Okay? So that's kind of working backwards. Just given the configuration, I can find the period, block, and group number, as well as what the element is. Okay? So let's try a few more of these. Let's try looking at argon 4s2. Just based on this information, I know it's in period 4. I know it's in block S. Okay? Then I know it's in the second column of the S block because it has 2 electrons in that sublevel. So I know that would be group 2A. Or I could also write the alkaline earth metals. So let's look at one more of these. Let's say we have argon followed by 4s2 3d7. Okay. So the period here, because it ends with a D sublevel, we know we count the D sublevel down 1. Okay? If you were to look at the periodic table, there is no third period D block. Okay? If you look, it just doesn't exist. So because we know that we count the D block down 1 row, we know this is in the 4th period. Okay, so it's in period 4. The block is D, and it's in the 7th column of that D block. Okay, so the group is just 7B. Okay, we don't have a special name for the transition metal groups. So this is something we learned last chapter. It's not anything difficult, but it's something if you have this skill and can very easily determine this information, then you can go match it up to the periodic table and find the element very quickly. Okay, so let's look at 1 or 2 examples kind of going in the other direction, going from the element on the periodic table to the outer electron configuration. So let's look at calcium, for example. Okay? So if I were to write the noble gas configuration, I would jump up to argon. Okay? So the first 18 electrons in the noble gas configuration would be accounted for with argon. So I only care about these last 2 electrons for the outer electron configuration. So if I think about where these electrons are falling, they're in 1, 2, 3, 4. They're in the fourth period. They're in the S block. And there's 2 of them. So the outer electron configuration for calcium would just be 4s2. So if I wanted to think about phosphorus, for example. So if I had phosphorus and I wanted to write the noble gas configuration, I would jump up to the noble gas on the previous period. I would say it's neon. So that accounts for 10 electrons. I need to account for 5 more of them. So after neon would end in the 2p6 electrons, I would have to come back and I would have to account for the 1, 2, 3 s electrons. And I would need both of those. I would go here and here. Then I would come across to the 3p. Okay, the 3p block. Now I would do p1, p2, and p3. I need to add 3 electrons. So now I have added the 5 electrons necessary to go from neon to phosphorus. So if you can do this without having to go through the alphabet diagram, just going through the steps I just did, it'll make your life a lot easier in the future when we do these to solve more complex problems. So hopefully this wasn't anything difficult or even really anything new. It's just using some of our past knowledge of electron configurations to take another little shortcut to write only the piece of the electron configuration that I care about, the outer electron configuration.